everybody. Today we're going to talk about OPA and Argo and have some time. So let's start. So first, a little bit about ourselves. So Dana is my amazing colleague. She is security engineer in JFrog in the last 3 years. She is fucking awesome, and she just finished her conditory tour for 12 months.
Thanks.
So she's super talented.
Oh, thanks. And Batel is our talented developer advocate in JFrog for the last 6 years. She has 2 crazy doggies and a little cutie one named Ethan.
Thank you. All right. So are you ready to start? Make some noise, guys. Come on. All right, so we have only 10 minutes, so we'll try to cover everything, but if not, we'll just talk later on. So today we're going to cover one of the OPA Gatekeeper constraints.
We will talk about why and how to allow private Docker registry only for your Kubernetes cluster, how we deploy it using ArgoCD, and the full journey from warn to deny.
Okay, cool. Thank you. So there are some Easter eggs that we just hide inside the presentation. Try to catch them all. Let's see if you will find them. So as Lori said before, and other people, we always start with the why, right? We love to say, first of all, why we need it. So there are many reasons why we need a private registry. And here are the 3 main reasons that we focus on.
Yeah, so the first one is a single source of truth. We must trust our Docker images everywhere, particularly in production. So we need to have one single private repository to store them all.
All right. The second one is compliance and regulation, as we wrote here. The sky's the limit. You can define and enforce your own security check to secure your software supply chain and enforce regulatory and governmental regulation. So this is the second one. And the third one?
Yeah, last but not least, vulnerabilities. Vulnerabilities are everywhere. Developer and DevOps infrastructure are the main attack vector in the supply chain attack. So we must scan our production images.
Okay, cool. So here's our story. First of all, the DevOps team already implemented ArgoCD, and you heard about Argo, so I won't tell too much about it. It's an open source continuous delivery system that compares the runtime against your Git repo, which means GitOps, as all of us love, and thanks to Chen and Lior.
Yeah. The security team wanted to implement OPA Gatekeeper, an admission controller that validates requests to create pods on your Kubernetes cluster according to your custom-defined policies.
All right, so we shake hands to work together on this project. Thank you. And some of you already heard about Kubernetes. You probably know where OPA lives, but just to make it clear, OPA lives alongside API, as you can see right here. And now let's talk about OPA Gatekeeper configuration.
So open
we'll get there. So open it to YAML files.
Yeah, indeed. The first one is the constraint template, your actual policy, a schema for a specific kind of Kubernetes object you would like to validate against its spec. In our use case, we check the repository of container and init container Docker registry against our repo's global parameters.
Now let's talk about Rego, like you mentioned. Rego. All right, so some of the people really like Rego, right? Who likes Rego? And some of them hate Rego, right? I think it's readable. I like Rego, but she won't agree with me. Yeah. So Rego is really, I think it's pretty readable. I like it. And it's really easy to customize it, right? You can write your custom policy on every key in your spec deployment, such as no host path in the mount volume or non-root user in security context. And if you really want, you can use JSON schema too. So now let's talk a bit about the gatekeeper constraint.
Yeah, so the second file is the constraint, which holds 3 main settings. The first one is kinds, the Kubernetes objects you would like to compare the policy, the constraint template against on. Second one is the enforcement action, the actual action you want OPA to take, warning for auditing and deny for full enforcement. And the last one are the parameters you want the constraint template to compare the policy over.
Awesome. So now let's deep dive a bit. So in this example, we're defining pod as our object, apply the warning template over here, sorry. So here is the warning that we got whenever we configure OPA. And as you can see here, we got OPA Gatekeeper violation, like I said, and we got the warning on a single pod deployment. However, as you know, pods are the smallest unit that we can define, right? Everybody agree with that? There is nothing else. Cool. What, sorry? All right. So if we want to expand our audit to more object kinds, we can watch and return warning on them. Like this, we apply it. Awesome. And now we can add the deployment to object kind to the constraint like RBAC in Kubernetes. But do not forget to edit also the template itself, right? We want to make sure that we are covering everything.
Now, let's talk a bit about ArgoCD side of things. With Argo, we achieve OPA as a service. Once we created a production branch, Argo compares the live state against the desired state and checks if the CRDs of the gatekeeper system's objects need to be updated or not. By dividing Argo branches to production, dev, and stage, policies, exclusion, and enforcement action can be different between your environments. And another benefit in ArgoCD configuration is the sync policy. In the production, we decided to not automatically roll out the unupdated CRDs. This helps us to control the rollout phase. Cluster by cluster, and during it to monitor the performance and make sure that there is no business impact.
So we created Grafana dashboard, which is open source analytics and monitoring tool to see the current state of our production policies. And the most interesting part, of course, is the validation webhook response time to make sure that it won't take too long.
Yeah, this graph helps us to understand if a new constraint will cause a delay in pods creation.
Okay, cool. So let's summary everything, right? Let's summary our journey. So in summary, to pull all of this effort into a single timeline, we started with logging and monitoring rules way before we implemented OPA, right? We have to make sure that we are monitoring everything.
Yeah, we deploy OPA in dev and stage cluster and then understood that production is a completely different creature from dev and stage. So we move very quickly in warning mode in production. Now hygiene, the next phase is hygiene, which in my opinion is the most important phase. DevOps cleanup contains many findings. Most of them were third-party vendors like Nginx and Filebit. We discover lots of leftovers from POCs and analysis tools that we ran, for example, KubeShark. We collected OPA violation logs according to Elasticsearch through this whole phase, and this way we saw the number of violations decreasing.
Oh, all right, that's great. So once there were no more new violations, we ran a few tests and moved forward from warning to deny. So let's talk a bit about the achievements, right? Across all the entire project, we were data-driven. We made sure that we have Prometheus as our open source monitoring system, which help us to understand if the constraint is not overloading the Kubernetes API. And we collected, of course, also OPA violation logs to Elasticsearch to be 100% sure that there are no new violations and production will not break.
Yeah, so this project was so successful that after the hygiene, DevOps asked us to maintain this effort. And after this request, we moved to full enforcement. And now we are successfully pulling all our Docker images from internal repository, which achieves our 3 initial goals. The first one is single source of truth. Second is compliance for security checks. And last, to scan your vulnerabilities.
Awesome. Woo. So today the awareness created by this project enable our DevOps team to start working with a private registry, as Dana said before, and we move it also to production, which is pretty impressive.
Yes, so did you get it? Every single project that we use is a CNCF project, which shows the value and the importance of open source and vendor natural tools.
So we love to build our own solution, and we would love to donate more and more code to the CNCF and work on open source project like we have in JFrog. So it's really a pleasure to take part of this project.
Yeah.
And I hope we have some time for questions. Anybody? Any questions? Whoa.
Okay.
Okay, cool. Thank you guys.
Thank you so much. Thank you.